So when you're solving an equation like this with the variables on both sides, we have the 4x, we have the 10x. Because they're on opposite sides of that equal sign, one's on the left, one's on the right, we can't just combine them. We can't do 4 plus 10 because you can only combine stuff on the left, you can only combine stuff on the right.
Gotcha. Okay. All right. Maybe that's where my problem is coming in, is that I'm trying to combine it. And then when I go through and do all the additional steps, I never come out with any of the 4 options for an answer.
Okay, so that's a good place to start. So instead of combining, what you have to do is use opposites. So because this on the right side is the positive, to move the whole thing, the 10 and the variable, sometimes we divide just to move the number, but this time we're going to minus it to move the whole thing over. When you move it to the opposite side, use the opposite sign.
Okay.
Because really that goes to 0, so it goes away. 10 minus 10 is 0, and 0 just gets rid of everything. On the other side, we do that and now combine that together. So what do we get when we combine these?
That would be a -6 then?
Good.
Okay.
So now we have just one variable, which is one of our goals. We want to get down to just one variable. But we still have to get all the rest of the numbers over. We don't want x to have any numbers with it. So we have that -6, we have the 47. Now we just do our normal opposites with the numbers. So what opposite would you normally do right now?
Well, I would assume that the next step would be to minus the 47 from the 27. Okay. And then this is where I get kind of hazy, because I know that there's a 6x, and because the x next to the 6 would mean it's a multiplication, we're supposed to do the opposite of that, correct?
Correct.
Okay. So it would still keep the negative on the 27 minus the 47. Right? Okay.
Yep.
Okay, so
and if you don't want to do those in your head, use the calculator. Just type in 27 minus 47 and pop the answer out.
Okay. Now, at this point, I would be doing the 20 divided by 6, correct?
Yes. So when we're dividing, we don't change this sign. This is still going to be dividing by a -6. Because our opposite isn't opposite of minus, our opposite is opposite of multiply, like you said. Really, there's multiply here, so we divide.
Okay.
To cancel that out. But the important part is now this -20 divided by 6, which is going to come out as a decimal. That one for sure you would want a calculator on.
So it's 3.3, and that's reciprocating, but when I go to do, like if I was to do the reversal and put that 3.3 in where the x is for the actual first equation, it should come out even on both sides then, correct?
Correct.
Okay.
Because it is a decimal that we're going to have to round. You're saying this is 3.3 forever. We can't type 3.3 forever into a calculator when we simplify. So it might be a teensy bit off since it's a decimal. Not many of the problems have that issue. Most of them just come out as one nice number.
Okay.
But this one, since we'd have to round, usually I ask you to round to the nearest 10th. So just 3.3.
Okay, because it's under 5, so you would round lower.
Yep.
Okay.
Yep.
Okay, so that all makes sense.
Okay.
Now, there was one other question I had in regards to that. Oh, how do I turn that into a fraction when I'm showing the final, my final answer for that? Because some of the questions that I've had, it doesn't show it as a whole number or as a number with a decimal. It shows it as a fraction. And that really throws me for a loop.
So instead of using a calculator at all to create that decimal, we're going to go back to this part.
Okay.
-20 over -6. So first we think about any positive or negatives. If it's a negative divided by a negative, does that come out positive or come out negative?
they should cancel each other out, so that becomes a positive, correct?
Yep. So our
Okay.
answer is going to be positive, which we don't write the symbol positive.
Right.
So then the 20 over 6, we need to reduce this fraction. Every answer for a fraction will be in its simplest form.
Okay.
So when you reduce a fraction, you look for one number that divides into both of those. Can you think of one number that divides into 20 and also divides into 6?
Let's see. Not 6.
No, not 6, or else it would have divided nicely in the first place.
Right. Is it? No, because 3 doesn't divide into 20 evenly.
Okay. So you thought about 6, you thought about 3. What's the only thing left to divide into 6?
1?
1, or I guess I forgot about 1. I wasn't thinking about 1 because 1 doesn't change anything.
Right.
So you divide by 1, it's still 20 over 6.
Uh-huh.
What about 2?
Oh, yeah, it would be 2. Mm-hmm.
Yep. A lot of the times it's 2 or 3. Not always, but a lot of the time 2 or 3 will work. So if your answer is left like this is called an improper fraction when the top number is bigger.
Right.
So that's as simple as you can go as an improper fraction. If it's a mixed number, you divide the 3 into the 10.
Okay.
So how many times can 3 go into 10?
3 times.
3 times. Then we do the multiply. 3 times 3 is 9. And we subtract, so we have a remainder of 1.
Uh-huh.
So the part on the top, that's the main part of your mixed number. You have 3 times it went in. And
Okay.
then the remainder, that's the top of a new fraction next to it.
Uh-huh.
And then what you were originally dividing by, that's the bottom of the fraction.
Oh, okay.
3 1/3.
And it always works out that way.
Yeah, you always do the division, and then it's always, this is the main number, this is the top of the fraction, this is the bottom of the fraction.
Okay. So whatever's remaining is the top number, and then the bottom number is what the number you divided by was. Okay, I got that. That makes sense.
Good.
Okay. All right.
Any other questions from your course?
There was something else, but I have to find out where it was. Hang on one second.
Okay.
-10 plus 3x plus 5 equals 18 minus 2. Now, my question in regards to this one would be, I know that we have the, where the equal sign is, we're dividing it into the 2. I know that we need to add the exponents together if they're in the equation, but there isn't any. And then from that point, my question would be, the 18 minus 2, would I just be subtracting that and it would be 16 on the one side, or am I jumping the gun as far as that's concerned?
Nope, that is exactly right. So since they're both on the same side, you just do whatever signs are already there. You just do the 8 minus 2.
Okay, cool. And then for the other half of it, I would take the -10, but would I be doing plus 5 because the plus sign is before the 5 to combine the 2?
Correct.
Okay. And then once I do that, it would be adding the 3x to that, correct? You'd be dropping that down just the way that it is?
So you could say -5 plus 3x. That would work. Or you could say 3x minus 5.
Okay.
Either one is correct.
Okay, and then at this point, I would do the opposite for the 5, so it would be a plus 5, and then it would go with the 16. So we're at 21, and then I would do the division at that point. I would be dividing the 21 from the 3.
Good.
Okay, yeah, because that's where it was confusing me, was if I was correct in doing, since it's on both sides, I would be strictly doing the 18 minus the 2 on that side and then leaving it alone until I move further down.
Correct. Yep.
Okay. Well then, and then how does that work if I'm doing it with an equation similar to that, but it would be in parentheses?
Okay. So I'm going to make up a random one.
Okay.
I have no idea how well this will work out or not. Might get a really weird answer. So we start the same way. Split it into the 2 sides.
Mm-hmm.
Instead of going straight for combining anything, like we did the 18 minus 2 on the last problem, we have to take care of the parentheses first.
Okay.
And parentheses are a type of multiplication. It's saying to multiply by the 3, but to both things on the inside.
Mm-hmm.
So multiply it by the 2x and multiply it by the minus 1.
Okay. So we would have the 6x, and then that would be a negative 3, correct?
Yep.
Okay.
And if it come out positive, like if this were negative 3, you put plus 3, because you can't just put 6x3. There has to be a symbol. Usually we don't put the plus, but that's one of the few cases where we would.
Okay, so I would be doing the plus because the two cancel each other out. So that's how I would be figuring that further in the equation.
Yes. Yep.
Okay. All right. Because that's where, that part was starting to confuse me a bit. So now for this part, because it's 2 separate equations that we're going to be bringing together, I'm not going to mix that 2x with the 6x, correct?
No, because
Okay.
yes, the 6x is on the left, the 2x is on the right. So we're not even going to worry about those yet.
Okay.
We are going to now combine what we can.
Okay. So then we would take the negative 3 plus the 5, which would be a negative 2.
Careful. Which one's bigger, the 3 or the 5?
The 5 is bigger.
So you keep the plus sign.
Oh.
When it's a negative and a positive, the bigger number determines what the sign is for your answer.
Okay. And that one stays the way that, okay.
Yep. Because the right side had nothing to combine. So now you've got to do your opposites with your variables. The 6 and 2x can't just combine, but we can move the 2x over to the 6.
Oh, and this is where it was getting me. Okay, so then I would be would I be adding it because it's a positive? So it would be a positive 2x plus a positive 6x?
Because we're moving it to the other side, we want to do the opposite. If we added it, 2x plus 2x is 4x, and it doesn't get rid of the 2x.
Oh, okay, yeah.
We're choosing to minus it so that this 2x cancels.
So it disappears entirely. Okay, so then that would be 4x plus 2. Where do I add that 10? I don't. It just drops down?
It just drops down. It didn't have anything on the right. If there were more things on the right, you could combine it with the 10. But if there's nothing on the right with it, it just drops down until you do your next opposite.
Okay. Step. So then I would minus 2 from the 10.
Mm-hmm.
Okay, so we would have the 8, and then 4x equals 8, and then I would do the division the same way that I would do it before. So, okay, 8 divided by 4 is 2, so x is 2.
Good.
Got it. Okay. Okay, then it shows me where I was making the mistake with it, because I was getting all sorts of weird numbers.
Yeah, yep. So the key things to remember, just a little recap. If there are parentheses, do those first.
Mm-hmm. And that's
If
always
there's
multiplication?
always multiplication.
Okay. Mm-hmm.
If there's stuff on the same side, so if there's anything on the left you could add or anything on the right, you do combine. If there were a variable, just a pretend situation again, if there were a 3x, you would combine the variables on the same side.
Okay.
So that can happen. It doesn't happen as much, but it can.
Okay.
So combine what you can, then you do opposites. So this is the key one to remember. If it's positive, when you move it over, change it to negative. If it was negative, when you move it over, change it to positive.
Okay.
And that's different. If there had been the 3x here where they're on the same side, you would just do 2 plus 3.
Okay. And it
Because
was still a positive because the final answer for that equation is still a positive?
Mm-hmm.
Okay.
Yep. Okay. But when you go to opposite sides, that's when you change the sign. So if it's all on the right, keep it the same. If it's moving to the opposite, change the sign. And then it's just your normal opposites after that.
Okay. That helps a lot. It totally makes sense now because I was all over the place trying to figure out, and I shouldn't have been adding the two sides as quickly as I was.
Yep. And that is one of the problems of problems like this. If you do miss one step, it does mess up the rest of the problem, even though you had all of that down pat. There was no issues with the ending part.
Right. It was just where I was combining it.
Mm-hmm.
Okay. Well, thank you. That made everything that much easier because I just could not understand where I was getting it wrong. So that's awesome.
Okay. So if you have questions again and there's no live session that's coming up anytime soon, you can send me a chat message. My name's April Barton, by the way. I should be your math teacher because I think you heard about my chat message that I sent to you guys.
You're not. My teacher, I think, is Mrs. Whitehead.
Okay. So you can contact her as well for live tutoring.
Okay.
Either via chat or via her email.
Okay.
So she can do a session with you. You can contact me if you have questions.
Okay.
And are you part of like the Ohio program or Michigan program?
Michigan.
You actually have access to online tutoring all the time. They don't talk with you like we're talking. It's just using a whiteboard and you chat back and forth.
Okay.
But when you click the need help button, there should be a button that says online tutor.
Okay.
And that doesn't. Okay. Yep. And that doesn't connect you to me or Miss Whitehead. We contract out with another company so that it's literally all the time. Me and Miss Whitehead mostly work normal daylight hours, but if you're working at 2 a.m. and you want some help, they can help you. You have to answer a few little questions to actually then get to the tutor, but it's free for you. So it's another great resource to be like, I want to figure this out right now. I don't want to wait to contact my teacher.
Oh, that would have been awesome because I was struggling so hard last night because I only have a certain amount of hours in which I can try and, work on this where it's quiet time. And I saw they sent me an email this morning about this tutoring session because I've never done it before. I've never needed to. So when they sent me that, I was like, okay, maybe I can get some answers this way and then I'll be able to move along. I just needed something to make it click and I got it now.
Good.
So. All right. Well, awesome. I thank you for your help. How does this work now? Do I just